discussion on choppers and inverters. Now, beta, many of these questions we might have already seen in the assignments in the class. So we will skip that and we will see the questions that we have not yet discussed. So without wasting any time, let me start the first question. This we have already done. The current was 1 ampere, right? The average output voltage was 8 volt. Try this one, beta. Try this one. This we have not done. चलो 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 ट्राई करिए. Seven. देखो, the basic method of finding the average output voltage is the volt second balance. We can see that there is only one inductor. Okay. There is only one inductor. So the question says S1 is turned on for 0.2 millisecond, S2 for 0.3 millisecond. This one will be on. For next 0.3 millisecond, S2 will be on. Five minus V naught. So V naught comes out as 7 volt. Okay. We will solve it from the very basic. V naught comes out as 7 volt. Clear? This we have already done yesterday. The answer was A. Okay. Try this. What is, ये भी कर रखा है क्या हमने, एक बारी बताइए भाई. What is the value of R that will make inductor current just continuous? This is based on buck converter. Have we already done this? जल्दी से बताओ. ये भी हम लोगों ने कर लिया है क्या? मेरे ख्याल से कर रखा है ना. ये वाला भी हमने कर रखा है. चलो ये वाला ट्राई करो. I think this we have not done. बनाओ भाई. कितना है भाई? 0.4. देखें. देखो हम लोग क्या करते हैं, जब इंडक्टर का वोल्टेज पता होता है, ये अप्लाई वोल्ट सेकेंड बैलेंस, तो 30 × dt. Okay, T will be common. So D will come out to be 0.4. ठीक है, D will come out to be 0.4. ये वाला हम लोगों ने कर लिया था भाई. पीक वोल्टेज अक्रॉस द स्विच इज 60 वोल्ट. ठीक है. RMS करंट इन द सॉलिड स्टेट स्विच, ये ट्राई कीजिए. RMS स्विच करंट निकालिए. 3.513 देखें. Now beta, this is a boost converter. Ten ampere. Duty cycle is 0.1. Okay. Delta IL. So we will not take the ripple because frequency is unknown. So instead of computing ILRMS, I will directly use the value of average. Okay. Which means, beta, I am ignoring the ripple in the inductor current. Why? Because frequency is unknown. I cannot calculate the ripple. फ्रीक्वेंसी अननोन है, रिपल नहीं निकाला जा सकता, इसीलिए रिपल इग्नोर किया जा रहा है. ये वाला तो हम लोग कर चुके हैं. सुयश भाई कोई बात नहीं, अगर नहीं हो पा रहा है रेक्टिफायर, बाकी चीज कर लो. और रेक्टिफायर में भी जितना सेक्शन हो सकता है उतना तो करो, पूरा रेक्टिफायर छोड़ने की जगह. ये ट्राई करिए भाई. ये नहीं किया है ना हम लोग, एक बार कंफर्म करो भाई. पीक करंट ड्रॉन फ्रॉम द सप्लाई, ये हमने किया या नहीं किया? पीक करंट ड्रॉन फ्रॉम द सप्लाई. चलो करो भाई. आया भाई, 40 एम्पियर आ रहा है. देखिए, दिस इज अ बक बूस्ट कन्वर्टर. ड्यूटी साइकिल इज 0.6. is 7.5. Now delta IL dVs by FL. Now what is F? 10 kilohertz. L Now beta, the peak value of inductor current is same as the peak value of source current. Always remember, through any part, only the inductor current flows. So if I ask you the peak value of switch current, source current, diode current, everything is same as the peak inductor current. Chaliye, next. This was a very beautiful question asked in GATE 2018. Let me explain. The figure shows two buck converter connected in parallel. The common input DC voltage, okay? The common input DC voltage of both the converters is 100. Okay? The inductors are of identical value. Load resistance 1 ohm. Capacitor has negligible ripple. Both operate in continuous conduction mode. Switching frequency is 1 kilohertz. Control signals are given to us. Assuming converters share the load equally, what is average current of switch S1? तो देखो बेटा, basically this is known as multi-phase buck converter. Essentially what it is two separate buck converters sharing same source and same load. Okay, जिनका सेम सोर्स और सेम लोड है. Now beta, for half cycle 0.5 millisecond S1 is on, for rest of the 0.5 millisecond S2 is on. Okay, focus on any one inductor. ठीक है, तो 0 से T/2 S1 is on. Suppose I say this is VL1, 100 minus V0. Now beta, from T/2 to T, yes, S2 is on, but I am focusing on the upper inductor. The D1 has to be on so that inductor can discharge. So that inductor can discharge. So if we apply volt second balance, because we know why do we provide the anti-parallel inductor? So that, anti-parallel diode, so that inductor can discharge easily. So V0 comes out as 50. Now the question is very simple. First of all, capacitor voltage has negligible ripple, so V0 is constant, 50 ampere. So what is output power? V0 I0 2500 watt. Now all components are ideal beta. So what is input current? V in is 100. Now beta, both converter share equal load, therefore so they will share half of the supply current. दोनों इक्वली शेयर कर रहे हैं, तो सप्लाई से आने वाला करंट इक्वली डिवाइड होगा. So half current will go into S1 and half will go into S2. So the answer will be 12.5 ampere. And this was the question asked in GATE 2018 IIT Guwahati. This year also IIT Guwahati is conducting an exam. So be very focused on power electronics. चलिए, ये वाला क्वेश्चन था जिसका फिगर मिसिंग था. आप ट्राई कीजिए. मैंने बोला था इसको PYQ में करा दूंगा. Try this. I want to know the power transferred from B1 to B2. ठीक है, I want to know the power transferred from battery 1 to battery 2. Try करिए. अब देखें. In this question, beta, it is a boost converter. They have given the input voltage, they have given the supply, they have given the duty cycle and the output voltage. They want to know the power that is going into battery B2. Now again, beta, the information is more than required. So let me check. 0.6, that is 3 by 5. So now the given V0 is higher than expected. So there will be discontinuous conduction. Okay, there will be discontinuous conduction. Theta will be 0.6. Now, beta, in discontinuous conduction, how do we represent the inductor current? This is the most important graph of the discontinuous conduction, the graph of IL. 0 to dt it charges, then discharges. And then stays 0 till t. Now, मेरे बच्चों, during this time the switch is on, and during this time the diode is on. So when diode is on, then energy is absorbed by P2. Now, how to find the peak current? The peak current is same as the ripple. Vs by FL 5 maybe to 0.8 ampere. Now, beta, when diode is on, okay, so current going into B2 is IL. जब diode on होता है, so what is energy in B2? That is power integration. So power but this will happen from dt up to beta t because during that time actually the power is absorbed by battery. So the maximum current is 0.8. I am taking the area of the triangle. 150 into 0.4. So answer will be 12 watt. समझे? मुझे कौन सा एरिया लेना होगा बेटा? मुझे ये एरिया लेना होगा जो dt से बीटा t तक जा रहा है. लाइक दिस. इसमें से कोई भी एमटीए नहीं हुआ था सुयश भाई, ये 2018 के जो सवाल हैं. ठीक है. आई हैव टू टेक दिस एरिया बिकॉज ड्यूरिंग दिस टाइम ओनली द एनर्जी इज टेकन बाय बैटरी B2. चलिए ये ट्राई कीजिए. A DC to DC buck converter operates in continuous conduction mode. 48 volt input, resistive load 24, switching frequency is 250 hertz. On duration 1 millisecond. What is load power? What is the power absorbed by the load? ये क्लियर हुआ भाई सभी लोगों को? क्वेश्चन नंबर 12. बेटा सिग्नल का हमारा क्रैश कोर्स खत्म हो चुका है पेड कोर्स में. तो अभी जो मैं यूट्यूब पे क्रैश कोर्सेज करा रहा हूँ वो कुछ पेड कोर्स के ही मैं करा रहा हूँ. तो मैंने 2 क्रैश कोर्स प्रॉमिस किए थे, एक पावर इलेक्ट्रॉनिक्स और एक ईएमएफटी. ईएमएफटी परसों से स्टार्ट हो जाएगा. तो देखो ड्यूटी साइकिल now beta there are 2 approaches to this. If we consider power is 12 square by 24, 6 watt. E not having ripple because nothing is said about capacitor. It is not saying anything about capacitor. Because they did not give the circuit, they did not tell you about the capacitor. So you cannot know possibly if the load contains a capacitor or not. Okay? That is why beta gate gave both the answers as correct, 6 and 24. 12 एक बार और समझा दूं. सबसे पहली चीज तो शदान भाई 12th क्वेश्चन के अंदर आपको इनपुट भी दिया, आउटपुट भी दिया, ड्यूटी साइकिल भी दी. तो यहां से शक पैदा हो जाता है कि डिसकंटीन्यूअस कंडक्शन होगा. भाई मैंने प्रूफ किया. फिर मैंने क्या किया, इंडक्टर करंट का ग्राफ बनाया, पहले बीटा निकाला. बिकॉज इन डिसकंटीन्यूअस कंडक्शन आउटपुट इज इंस्टेड ऑफ डी we place d by beta in the formula. I found beta. Then I draw the graph of inductor current. Now when switch is on, the current flows in this loop. It does not reach the battery B2. When diode is on, the current reaches the battery B2. So B2 will absorb the energy when diode is on, that is from dt to beta t. For this triangle, I need peak. Peak current is nothing but the ripple dVs by FL. Now during this time, battery is taking energy, but because current is variable, energy or power is variable. So for finding the power, first I find energy, V I dt. For finding power, I divide by the total time period T. Now V is constant, it is taken outside. I have to take the area only from dt to beta t because only during this time energy is taken by battery B2. ठीक है, चलिए ट्राई कीजिए बेटा. आई वॉन्ट टू नो द वैल्यू ऑफ द बूस्ट इंडक्टर इन माइक्रो हेनरी फॉर द बाउंड्री बिटवीन कॉन्टिन्यूअस एंड डिसकॉन्टिन्यूअस. करिए. आया भाई. Boost converter duty ratio is controlled to regulate V naught at 48. While input is 24. Okay. Output power is 120. Okay. Now, IL will be 5 ampere. What is the boundary condition, beta? That IL should be delta IL by 2. So 5 delta IL is EVS. So what is the inductor? EVS by 5, 2 into F. F is 50 kilohertz. 2.4 by 10 की power 5, 24 माइक्रो हेनरी. 24 माइक्रो हेनरी आ रहा है. चेक करो. चलो ट्राई दिस बेटा. एनर्जी स्टोर्ड इन द इंडक्टर एट द एंड ऑफ 10 कंप्लीट स्विचिंग साइकिल. ये ट्राई करो. देखें भाई ये क्वेश्चन, स्विचिंग फ्रीक्वेंसी दिए 10 किलोहर्ट्ज, ड्यूटी रेशो 0.6, सभी कंपोनेंट आपके आइडियल हैं, ठीक है। अब ये बताओ ये कैसा कन्वर्टर है? टू 200 जूल, आइए देखते हैं। तो ड्यूटी रेशो इज 0.6, ठीक है। ओके, L di by dt, what is inductor? 10 millihenry. So at 0 current is 0. What is the current here? C is 1 by F. Okay. Now beta, I want to understand what is the current at the end of one switching cycle. एक साइकिल के अंत में कितना करंट आएगा? तो at time dt beta my current was I. At time dt my current was I. So it is t minus dt. T is 0.6. So 0.4 by F. T is 1 by F. So at end of one cycle, IL does not go back to original value of 0 ampere, but IL is 0.1 ampere. So now at the end of 10 cycles, IL will be, in every cycle current will increase by 0.1. So energy ten millihenry into 1 square 5 millijoule. Okay. So answer should be 5. Answer आएगा बेटा 5. Understood? In every cycle, current will keep on increasing by 0.1, 0.1. So at end of 10 cycle, current will become 1. Okay. EC Gate 27 batch बेटा that will start in January. सिग्नल का बेटा अलग से क्रैश कोर्स आप नहीं परचेज कर सकते हो सुयश। चलिए ये ट्राई कीजिए बेटा। I am giving you the duty cycle. I want to know the resistance seen by the source. Very easy question. I want to know the resistance which is observed by the source. So resistance observed at any point is nothing but V upon I. So try to find the ratio of V and I at the input terminal. एक बार रिपीट कर दूं 15 वाला। 15 में देखो क्या बोला है कि इनिशियल करंट इंडक्टर का 0 है, तो 0 से dt तक बेटा वोल्ट सेकंड बैलेंस नहीं लग रहा ना, उसने ड्यूटी साइकिल क्लियरली दे तो रखा है 0.6। वोल्ट सेकंड बैलेंस का क्या मतलब होता है मीरबा? वोल्ट सेकंड बैलेंस माने कि इंडक्टर का जितना चार्जिंग हुआ उतना ही डिस्चार्जिंग, बट दैट इज नॉट ट्रू हियर। दैट मींस इन एवरी साइकिल देयर विल बी नेट चार्जिंग ऑफ द इंडक्टर। अब देखिए 0 से dt तक स्विच ऑन है तो 50 वोल्ट अप्लाई हुआ, dt से t डायोड ऑन है तो -50, यानी 0 से dt तक चार्जिंग तो dt से t तक डिस्चार्जिंग। ठीक है, like this. Charging, then discharging. Slope is same, 50 and -50. But every time, because the duration of charging is higher than discharging, so net current will keep on increasing. Are you getting my point? Every time the current is increasing by 0.1 ampere. Volt second balance says that inductor charging and discharging should be equal for a stable operation. That means this operation is unstable, like this. So every time beta current is increasing by 0.1, like this, because every time charging is more than discharging. Understood? तो यही चीज मैंने डिराइव करी है यहाँ पे। So from 0 to dt, V equal to L di by dt. Current at 0 is 0. Current at dt, I am assuming I. It comes as 0.3. Now the second sub-interval starts where the first one ends. So at dt, current is 0.3. I want to know what is current at t. So it comes out as 0.1. So देखो, at dt, current is 0.3. Then discharges by 0.2. So at t, it is 0.1. So that way compound effect will happen over 10 cycle. समझ गए? चलो, now let's see this. V naught is Vs upon 1 minus d. Now I naught is V naught by R, 3.75. Now beta, to find the supply current, (9.375). So resistance will be 15 upon Is, 1.6 ohm. वेरी गुड, 1.6 ओम। कुलदीप भाई डेसिमल का गलती हो गया। फाइंड एवरेज करंट ऑफ द इंडक्टर। कम ऑन, वेरी स्ट्रेट फॉरवर्ड क्वेश्चन। फाइंड एवरेज इंडक्टर करंट। आया भाई? तो V naught is D upon 1 minus dVs 60 volt. Now this is a buck boost converter. 1/4, 24 ampere. 24 ampere. See how easy it is to get 2 marks in such questions. Steady state current of inductor is given. Peak to peak ripple in the output voltage is 1 volt. Then what is the value of capacitor? Chaliye, try this. I want to know the capacitor value. C का value चाहिए, निकालो. Now beta, in straight line graph, the average inductor current will be the midpoint. Okay. Now, what happens is, I naught is IL. Now, duty cycle is 20/50. Okay. Now, this I min is greater than I naught, because of which delta V naught is, so capacitance will be 0.4 I naught by F. F is what? 50 microsecond. So 1 by F I am taking as time period 50 microsecond. Delta V naught is 1. 168 microfarad. 168 microfarad. Very good, Subhadeep. Answer is 168. So this direct formula is applicable if I min is more than I naught. Otherwise, we have to draw the graph of IC, then approach. चलिए try कीजिए बेटा. Average voltage across the 5 ampere current source. Average voltage across the 5 ampere current source. Actually, na, this is a type C chopper, which is combination of type A and type B. But khair, you can find the answer directly without any help from the concept of type C. देखो बेटा, this 5 ampere can flow via either S1 और via D2. या तो ये करंट S1 भेज सकता है या तो D2. ठीक है, तो 5 ampere can come from S1 and D2, which will make it a buck converter. Okay. So what is the average voltage? So duty cycle 3 by 10. 6 volt. Khatam. Because only S1 and D2 can provide this current, it will become a buck converter. If you reverse the current, then what happens? Okay. If 5 ampere reversed, then it will become type B. S2 and D1. Then V0 is VS1 minus D. ठीक है, तब ये फॉर्मूला आता है टाइप बी के लिए VS इंटू 1 माइनस डी. चलो ट्राई दिस. टाइम अवेलेबल फॉर THM when THA is triggered. In how much time does THM turns off? Many people ask me, sir, is commutation in the GATE syllabus? This is GATE 24 problem. चलिए बनाइए. How much time is available for THM to turn off once you trigger THA? क्या आ रहा है 50 माइक्रोसेकेंड. तो बेटा दिस इज क्लास डी. तो सर्किट टर्न ऑफ टाइम इज CVS by I0. तो 50 microsecond. Okay, whenever L and C are separate, it is class D. Very good. चलिए next, peak inductor current. I want to know the peak inductor current. This is a boost converter. Come on, everybody. So you can see every year they are asking question from the chopper. So chopper is very important. Okay. सर हम पढ़ाई कर रहे हैं बट एफिशिएंसी नहीं आता. एफिशिएंसी बेटा धीरे धीरे ही बढ़ सकता है, डे 1 से थोड़ी आ जाएगा. चलिए ट्राई दिस. पीक इंडक्टर करंट इन एम्पियर. देखो भाई, first of all beta, this is a boost converter. So duty cycle 1 minus d is Vs by V naught. Duty cycle is 0.5. Okay. Vs is given as 20, V naught is 40. I naught will be V naught by R, 4 ampere. IL will be I naught upon 1 minus D, 8 ampere. Now delta IL, dVs by FL, 10. So IL maximum 13 ampere. Answer will be 8 plus 5, 13. Very good, Abhishek. चलो अगला बताओ भाई. Power MOSFET is operated with a duty cycle of 0.4. I is 10, V is 15. What is the power delivered by the current source? कितना पावर करंट सोर्स से आएगा बताइए. So power of a current source will be V average into I. Try to find the average voltage across the current source. तो देखिए, when switch is on, voltage of current source will be 0. When switch is off, voltage of current source will be V. Okay. Because this will happen between dt and t. This will happen between 0 and d. $90. Okay. Answer is 90 watt. Whenever the switch is on, the voltage is actually 0. Very good, Subhadeep and Kuldeep. So last question of chopper, then I will move to inverter. The steady state capacitor current of a buck converter is given. If input voltage is 30, what is the value of inductor used? अगर इनपुट वोल्टेज 30 है तो इंडक्टर का कितना वैल्यू इस्तेमाल किया गया. देखो, दिस कैपेसिटर करंट पीक, so delta IL is 0.2. This time is dt by 2. This is dt. That is 30. ठीक है. And this is midpoint of 30 and 50. So duty cycle is 30 by 50.6. And delta IL is d1 minus dVs by FL. Now 1 by F is actually the time period. Time period is 50 microsecond. 1.2, 36 into 50, 1800. Are you getting 1.8 millihenry? Confirm karo ek bari. 1.2, 1.2, 36, 1800, 1800 micro is 1.8 millihenry. यही आना चाहिए. Very good, Subha. चलो. Now, beta, we have a three-phase current source inverter. What switch can we use to design a current source inverter? Think about it. For a current source inverter, what is the nature of the switch that is needed? Based on that, tell me what kind of switch should we use? Bolo bhai, what is the type of switch that we should use? The answer is A. Because for CSI, I need bipolar and unidirectional. For VSI, we need unipolar and bidirectional. So this is the only direction of current. MOSFET blocks positive, diode blocks negative. So bipolar and unidirectional. Yes, like SCR. So answer is A. यहाँ पे बेटा इस क्वेश्चन में VD 300 वोल्ट है. तो टेल मी द RMS वैल्यू. ये वाला हम कर चुके हैं क्या? RMS वैल्यू ऑफ लोड फेज वोल्टेज बताओ एक बारी. Have we already done this? RMS value of the load phase voltage. In 180-degree conduction mode, I need 3. Okay, very good. And what about the power, beta? The follow-up question, I need the power also. Power मुझे बताइए. This is star connected. Two thousand 3 kilowatt. Answer is D. चलो देखो, कल आप लोग पूछ रहे थे ना जब मैं आपको स्विचिंग पढ़ा रहा था कि सर ये सब पूछा जाता है या नहीं जाता है. देखो जरा, अल्फा लाइज बिटवीन 60 and 90. So this is one switching per quarter cycle. So what is the peak of the fundamental? You remember? ये मैंने कल बताया था. When alpha is between 60 and 90. So RMS of fundamental is given, which means peak will be 50 root 2. Otherwise, beta, if you go on to derive the Fourier series, it will take a lot of time. So how much will be the alpha? (77.15 degree). Now you understood, beta, how they will frame the question on the concept that I gave yesterday. Chaliye, try this. The triggering pulses to the switches are given The load current is sinusoidal. It is 0 at 0 pi 2 pi. You need to tell me the waveform for the node voltage VA0. लोड का करंट साइनोसोइडल है, VA0 का वेवफॉर्म बताइए. देखें भाई, अब देखिएगा. लोड करंट इज साइनोसोइडल. ओके, ठीक है. So from theta up to pi minus theta, S1 will be on. I'm only focused on A phase, beta. I'm only focused on A phase. And then S4. Okay. Now let me give you one more information. I already explained to you about the quadrants of operation. Why am I discussing about quadrants? So that I can understand the current direction. 1 2 3 4, तो ये 3 होगा. S1 S4. Okay. Now beta, during 0 to pi, current is positive. So either S1 or D1 will conduct. करंट पॉजिटिव है आपका. एक सेकेंड, नहीं, नॉट आई नॉट, उल्टा कर दिया. तो नाउ बेटा, बिटवीन 0 एंड पाई करंट इज पॉजिटिव. पाई टू 2 पाई, दिस इज द करंट. ठीक है. So if S1 conducts, if the S1 conducts beta, then VA0 will be VDC by 2. अगर S1 कंडक्ट करेगा तो VA0 will be VDC by 2. But what if S1 is not conducting? Then actually D2, D3 should conduct if S1 is not conducting for same current. For same current, D2, D3 should conduct. If D3 conducts, VA0 will be negative. D3 नीचे है तो VA0 will be negative. So beta, what am I saying? If S1 conducts, VA0 will be VDC by 2. If S1 does not conduct, for positive I0, D3 will conduct. S1 conduct करे तो बहुत बढ़िया, नहीं करे तो D3 चालू होगा जिससे V0 नेगेटिव आएगा. Now, from pi to 2 pi, if S3 conducts, V0 will be negative. If S3 does not conduct, D1 will conduct, because of which VA0 will be positive. S3 नहीं करेगा तो D1 करेगा, और D1 करेगा तो V0 नेगेटिव आएगा. V0 पॉजिटिव आएगा. D1 S3 VDC by 2, because you are only talking about one pole voltage. Okay. So in A, how many switches and diodes are there? S1, D1, S3, D3. तो आंसर क्या आना चाहिए इसका? लॉजिक क्लियर हुआ सभी को? बोलो भाई, लॉजिक क्लियर हुआ? When will be our interview results of JKSB? इंटरव्यू रिजल्ट्स मतलब समझा नहीं. ये वाला क्वेश्चन देखिए बेटा. दिस इज बेस्ड ऑन साइनोसोइडल PWM. So full bridge inverter has a output frequency of 50 Hz. Unipolar PWM is sinusoidal PWM with frequency 50 kHz, modulation index 0.7. Vin is given. So what will be VR? The peak of fundamental will be MAVin, that is 70 volt. We want the amplitude of fundamental at the output. मुझे आउटपुट पे जानना है बेटा. ठीक है. So I know the output of the output of the inverter, but I want the output across the resistor. Now beta, we are talking about fundamental. Now first of all beta, fundamental is sinusoidal. So I can apply the AC analysis. So what is the inductor reactance? Inductor is 9.55. So omega L. $100 pi. Three ohm. XC 1 by omega C. It is 63.66. $50 ohm. Now beta, Z will be R parallel 1 by J omega C. Resistance is 5. So देखो, this question cannot be asked in this year gate, like why? Because this requires complex calculation, so you need to have a offline calculator. So till offline calculators were allowed, this kind of questions could be framed. So that is my answer, 62.77. गौतम भाई, मैंने कल भी बोला था जब होगा तो आपको इन्फॉर्म कर दिया जाएगा, अब रोज रोज रिमाइंडर देके तो फायदा नहीं. Now see, the switches T1, T2 are switched in a complementary fashion with sinusoidal PWM. This is modulating voltage, that is the reference. This is carrier. We need to know the peak value of 100 Hertz component of the load current. चलिए, let me give you a hint beta. Based on the modulating voltage or the reference signal, the frequency of this is 100 Hertz. So when it says 100 Hertz component, it is by default talking about fundamental. In sinusoidal na beta, it will always talk about fundamental. Try karo. देखिए भाई, so this is a half bridge inverter. Peak of the reference, peak of the carrier. When you want peak of the fundamental current, resistance is given as 12, reactance as 16, 10 ampere. Simple. 10 ampere. Okay. This is the type of question that can be framed on sinusoidal PWM. A single phase full bridge VSI is fed from 300 volt battery. A pulse of 120-degree duration is used to trigger appropriate device. RMS value of fundamental voltage. Because there is single pulse of 120 degree, this is single pulse modulation. ये सिंगल पल्स मॉड्यूलेशन है, बनाइए. कर चुके हैं क्या सुभादीप भाई वाला हम लोग? P01 RMS or RMS divide by √2. This is from the Fourier series. I am taking n as 1. Now pulse width is 120 degree. So D will be 60 degree. So answer is sin pi by 2 is 1. चलिए नेक्स्ट, ये वाला तो मेरे ख्याल से हम लोग कर चुके हैं. कल ही कराया था ना ये. वी कन्वर्टेड डेल्टा टू स्टार. ये वाला भी हम लोगों ने कर लिया था. राइट, दिस वॉज बाय डिफॉल्ट स्टार कनेक्शन. ये भी हमने कर लिया था. चलो नेक्स्ट. Find the RMS voltage of the fundamental component of V naught. So V naught is a proper square wave. That means there is no modulation. If the inverter gives you a square wave, it only means one thing, that there is no modulation involved. It is called as the square wave mode. Square wave mode कहलाता है. So in square wave, this is the result. 198 volt. ठीक है, 198 volt. Peak of the fundamental component of phase voltage. I want to know the peak of the fundamental component of phase voltage in 180-degree conduction mode. फंडामेंटल का पीक चाहिए 180 डिग्री कंडक्शन मोड में बेटा. टू VDC by pi. Very good. Next, beta, again a question based on sinusoidal PWM. At 50 hertz, 50 hertz is the fundamental frequency. I am giving you the load power. You need to tell me VDC. मैं 50 हर्ट्ज पे आपको लोड का पावर दे रहा हूं, आप VDC निकाल के बताइए. चलिए. आया भाई? देखो पावर इज 1440 watt, which is IRMS square into R. IRMS is 6 ampere. So fundamental RMS is IRMS into Z. Now what is X? Omega L. Omega will be 100 pi because fundamental frequency is 50. So 30. Z will be root R square plus X square. 40 and 30 will make 50. 300. So what is the fundamental peak? 300 root 2. Now this will be M into VDC. Do not say VDC by 2 because each source is VDC. यहाँ पे दोनों sources VDC by 2 की जगह VDC लगाए गए हैं. तो आंसर विल बी सी. समझे सुभादीप भाई गलती क्या हुई? Don't just go after the formula. It has changed the naming of the sources. They are now VDC. Chalo, try this. The output voltage of a single phase full bridge VSI is controlled by unipolar PWM with one pulse per half cycle. One pulse per half cycle माने single pulse modulation. For fundamental RMS component to be 75% of DC, find the pulse width. So I am giving you that fundamental RMS is 0.75 VDC. You need to tell me the pulse width. Pulse width बताइए भाई. चलो. Sin D. Now this is given as 0.75 VDC. 3 by 4, 3 pi by 4. So D will be so pulse width is 2D. 112.8 degree. Okay, next let us see this 2020. A single phase inverter is fed from 100 volt DC, is controlled by a quasi square wave modulation scheme to produce VT. Angle sigma is adjusted to entirely eliminate the third harmonic. Under this condition of VT, magnitude of fifth harmonic as a percentage of fundamental. This is also single pulse modulation, but it is saying that we have adjusted sigma to eliminate third harmonic. Now you want to find the ratio of fifth harmonic and the fundamental. देखो बेटा, you can write the Fourier series as if you want to write in terms of sigma, now beta cos 3 sigma by 2 should be 0 because I want to eliminate third harmonic. Sigma is 60. So now when you want to find V05 by V01, sigma is 60, sigma by 2 is 30. Cos 150, cos 30 are same. So you can say magnitude it is asking 0.2. Magnitude wise it is 0.2. This is the Fourier series of a quasi-square wave. Let's try this. I want to achieve a modulation index of 0.8. Then angle theta should be, if I want to achieve a modulation index of 0.8, what should be theta? Where modulation index is the ratio of peak of the fundamental to the applied DC voltage. मुझे पीक ऑफ फंडामेंटल और डीसी का जो रेशियो है वो 0.8 चाहिए. आपको बताना है उसके लिए थीटा क्या होगा. बनाओ. देखो भाई, अगेन दिस इज अ क्वाजी स्क्वायर वेव. 4 into 325 by n pi cos n theta sin n omega naught t. So what is the peak of fundamental cos theta? That should be 0.8 times the DC voltage. So theta will be 51.07 degree. 51.07, 32.4 आ रहा है. Cos n theta by 2. थीटा ही तो होता है. cos n थीटा होता है. Sigma should be 30. तो यही आएगा इसका आंसर. चलो अगला ट्राई करो बेटा. आइडियल फुल ब्रिज सिंगल फेज इन्वर्टर विद डीसी बस वोल्टेज 1000. Inverter output voltage is shown below when diagonal switches are switched with 50% duty cycle. What does it mean? Diagonal switches माने the switches which are diagonally located. They will conduct together and they will conduct for half cycle. So duty cycle is 50%. Like S1, S2 for T by 2, then S3, S4 for another T by 2. So their duty cycle is 50%. Current is sinusoidal. I need to know the power. I need to know the power delivered to the load. देखो बेटा, for power, E and I must have same frequency. Now, when current is given as fundamental, what is V naught 1? 4 into 1000 by pi sin omega t. Current will be 10 sin omega t minus pi by 3. So now power will be 4000 by pi root 2, 10 by root 2, cos pi by 3. 20,000, 10,000 by pi. In watts I need 3183.09. So I will mark as 3183. Understood beta? I need the fundamental voltage because current is fundamental. ये देखिए, a three-phase grid-connected VSI with DC voltage 1000 is switched using sinusoidal PWM. Grid phase current, complex power is given. What is the modulation index? What is the modulation index? अब ये देखिए, S will be 5000. Now beta, for phase voltage in three phase, this is the formula. So 500, so modulation index is 1.1 by 3. 0.33. So remember, in three phase, for fundamental phase voltage, the formula is M into VDC by 2. Now see, this was asked in gate 24. Single phase full bridge VSI feeds a purely inductive load. Fundamental frequency, DC input voltage, inductance. ये निकालो फटाफट. Peak to peak load current. For purely inductive load, what is the peak to peak load current? फटाफट निकालो. For purely inductive load, what is peak to peak load current? So IP is VDC by 4FL. $200 425. Peak to peak will be 2IP. Very good, Subhadi. चलो, last question of PYQ. ये try कीजिए. Now I have told you beta how to deal with three phase sinusoidal PWM also. Karo. Then we will discuss assignments. देखो भाई, in three phase we have three reference waveforms separately for three phase at 120-degree shift. Modulating waveforms are compared with a triangular carrier. Carrier is same. In three phase PWM, carrier is same. The reference voltages are different. So amplitude of carrier is 1. Amplitude of reference is 0.8. Based on this, modulation index becomes 0.8. Okay. Now VSI has a DC voltage 600. Find the fundamental per phase RMS motor voltage. M into VDC by 2, 240. What about RMS? 169.7. कितना सिंपल सा तो क्वेश्चन है, ठीक है। चलो, now I will come to assignment of lecture 12. Voltage commutated chopper, source voltage is given, load current commutating component, minimum average output voltage. T on minimum is pi root LC. $314.16 and TC CVS by I naught, ठीक है, 8 into 250 by 20, 100. Now beta, V naught minimum is Vs, T on minimum plus 2TC divided by T. So it is 250, 314.16 plus 200. 1 by T is frequency 250. $32.13 volt. The option. ठीक है, very good. Bye. For the arrangement, circuit is in steady state with thyristor off. When the thyristor is turned on, ये वाला तो मेरे ख्याल से हम कर चुके हैं, right? So under steady state, capacitor is fully charged. When thyristor is turned on, thyristor current will be 200 by 100, that is the load current, plus capacitor current, the LC oscillator current. So peak current of thyristor would be 2 plus 200 root C by L, 22 amp. Okay, answer is voltage commutated chopper feeds the inductive load requiring constant current, turn off time, peak current, take a factor of safety, minimum value of duty cycle. ये तो हमने क्लास में किया है, राइट? ये वाला हमने क्लास में किया था ना, कम्यूटेशन सर्किट वोल्टेज अक्रॉस T2, ये वाला भी डन इन क्लास में हो गया। ये भी बता दो भाई एक बार आप लोग भी। मैक्सिमम करंट इन द मेन थायरिस्टर I naught plus ICP, because the LC oscillator current will also pass through the main thyristor. 70.7 plus 200 root C by L, ये हेनरी में होगा, तो 1 by 4, 170 points. Very good. The LC circuit is used to commutate a thyristor which is initially carrying a current of 5 ampere as shown above. The inductance and capacitance are given. So capacitance current will be like this. Okay. ये 20 ओम होना चाहिए ताकि ये करंट 5 एम्पियर आए. तो थायरिस्टर करंट विल बी 5 plus IC. What will be IC? 100 T by L is 10 की power minus 5, 10 to the 5 plus 10 sin omega. Now beta thyristor turns off when the total current is 0. मैंने जो करंट लिया है कैपेसिटर की पोलैरिटी के हिसाब से लिया है. ओके sin omega t is minus half. Omega t is 7 pi by 6. So time will be 7 pi by 6 root LC. Carrying a current of 5 ampere. ये ना मेरे ख्याल से ऐसे होगा कैपेसिटर का करंट जा रहा है तो या तो सब्ट्रैक्ट करना पड़ेगा. $52.35. ये ऐसे एक्सपेक्ट कर रहा है कि करंट विल गो अपोजिट एंड इट विल कैंसिल. क्लास डी कम्यूटेशन पीक करंट थ्रू द मेन थायरिस्टर. In class D it is I naught plus ICP. I naught is 120, ICP is 230 root 40 by 20. So it is 445.27. Circuit turn off time CVS by I naught 40 76.66. Circuit turn off time of auxiliary thyristor in class D 44.42. Okay, in the steady state VC and VD, तो V नॉट की पोलैरिटी ऐसे दिखाइए, माने एरो मीन्स इट इज फ्रॉम माइनस टू प्लस ऑलवेज. V naught polarity is opposite. But current because of 200 and because of V naught will be in same direction. ठीक है. At omega t equal to pi, current is 0. Diode will be off. So what will be VC? $450. What about diode? 200 minus 450 minus 250. बहुत बढ़िया शुभदीप भाई. One quadrant chopper feeds the RL load, resistance, inductance, supply, max and min, peak to peak ripple, average, duty cycle, current is continuous. So first let us check tau, L by R. What about the time period? 1 by 500, 2 millisecond. So now beta, because there is no EMF, the time period is 2. uh, 1 by 1.5. Psi max actually. Now I min, just the negative powers are replaced by positive powers. So this is the A part. I min गलत आ रहा है रौनक भाई, तुम्हारा I max तो करीब करीब सही आ रहा है. Peak to peak ripple is max minus min. .536. ठीक है. Average 0.555 volt. .5 ampere. In the voltage commutated chopper, commutating components, exact minimum average output voltage and circuit turn off time. $100 microsecond और T on min. भाई सेम ही क्वेश्चन आ गया क्या, क्योंकि वहां भी 100 आया था. वही क्वेश्चन है. E by R बेटा है नहीं ना, EMF दे नहीं रखा है. EMF is not given. यही वाला तो है सेम क्वेश्चन. ठीक है, चलो लास्ट असाइनमेंट. 3-phase VSI is operated in 180-degree mode. Which statement is true? In 180 degree beta, pole voltage contains third harmonic. but line voltage does not. Okay. This is done in PYQ session. Today we have done this. Okay. Now, in 180-degree mode, beta, phase and line are free of third harmonic. Phase and line both are free of third harmonic. Okay. Now, a three-phase VSI with ideal devices speak of the fundamental of the phase component. ये PYQ में हमने कर लिया ना. RMS output voltage at fundamental frequency 2 root 2 by pi VDC THD, we know in a single phase it is 48.34. Now, it is giving us a single pulse modulation with the pulse width of 120 degree, which means D is 60 degree. So, it is asking the THD. So, VRMS is VDC root 2 by 3. V01 RMS 2 root 2 by pi VDC sin D. D is 60, sin 60 root 3 by 2. So now beta for THD, I will calculate G. V01 RMS by V0 RMS, that is 3 by pi. Then I already know THD because this is same as three phase. 31.09%. Okay. 31.09%. Just a moment, बच्चों. Okay. Now, beta, in a single phase, we know THD and distortion factor already. See this question. In this question, what it says is that we are giving you a graph of the pole voltages. है ना? And we want the RMS value of the output. So this is the graph of the pole voltage. Now, how to calculate the output, मेरे बच्चों? For finding the output, okay, you must first calculate the difference of the pole voltages. So whenever both are unequal, the difference will be non-zero. And when both are equal, the difference will be 0. So Vs minus 0 is Vs, then 0. 0 minus Vs is minus Vs. Then again 0 minus 0 is 0. So you can see root pi upon pi, because duration is coming as pi, total is pi. Okay. Now this question is very good, beta. The pole voltages are now shifted by 45, just like they were shifted by 5. But I do not want the RMS output. I want the RMS at fundamental frequency. Now, beta, what is this 100, 0, 100? This is because we have two capacitors and we divide the supply voltage into two parts, each of 100. V01 RMS for square wave. This is the situation. Now, beta, the phase shift is 45. Now, fundamental is always sinusoidal. So, when we want to subtract two sinusoidal quantities, I can make use of the parallelogram law. V1 square plus V1 square minus 2 V1 V1 cos 45. When you want to subtract any other waveform, you have to basically beta use the graph just like we did in the previous question. But here what is happening is the fundamental value. Okay, the fundamental value is sinusoidal. और VDC by पोल वोल्टेज है ना शिट ये 2 होगा 68.9 समझे रौनक भाई 68.9 fundamental component of current. So first let us find out Z. Root 2 minus 45. ये 200 वोल्ट का तो I01 800 by pi root 2 is okay. Single phase full bridge inverter is fed from DC source. Fundamental component R XL XC is given. Again, same type of question. But this time it has directly given you the fundamental component of voltage. $81.3. Thyristor RMS. Each thyristor conducts for half of the total duration. कैसे नहीं So beta current I will take now because it is lagging by 45 degree. So 0 to 45 diode will be on, and from 45 in lagging this is what happens now. From 5 to 180 thyristor is on. So what is thyristor RMS? So what is the square of the current? 230 square by 8. One minus cos. Okay, integration of 1 will be, cos will be half sine 2 omega t minus 90. So sine 360 minus 90 is sine 270. Sine 90 minus 90 will be 0. Sine 270 will be minus 1. $21.87. फंडामेंटल कंपोनेंट ऑफ आउटपुट, ये मेरे ख्याल से आरएमएस दिया होगा, 2 से डिवाइड मल्टीप्लाई करो. फंडामेंटल कंपोनेंट आरएमएस वैल्यू ऑफ थायरिस्टर करंट. टी 1 minus cos 2 theta. $54.82 आ रहा है. कैलकुलेशन गड़बड़ हो रही थी. 54.8. चलो. Load current is sinusoidal. Similar question we discussed in lecture today ना बेटा. We want to know the waveform for VA naught. ठीक है. Similar question done in PYQ. So it will come out as T आएगा. When S1 is on, it will be VDC by 2. When nobody is on, then D3 will conduct. D3 will conduct. D3, S1, D3. Then S1, then D3. ऐसे conduction चलेगा. D3, S1, D3, S1, D3. Similarly here, when S2 is on, it is fine. If it is not on, D4. D4, S2, D4. We have to talk about S3. D1, S3, D1, 3. ऐसे चले. ऐसा ही क्वेश्चन मैंने क्लास में भी कराया ना आज, ठीक है। A single phase full bridge inverter DC input voltage third harmonic component of load current. So XL is 3 omega naught L. Okay. For PDC, (2.61). वेरी गुड रौनक भाई, ये वाला आज हमने किया है। ओके, पर फेज आरएमएस लोड करंट पीपीएच आरएमएस 600 into root 2 by 3. Okay, that is VPH RMS 200 root 2. Okay, per phase load RMS current. Okay. Now beta, this is output voltage having percentage of third harmonic. यार ये वाला ना स्किप कर दो, मल्टीपल पल्स मॉड्यूलेशन का इसमें काफी मेहनत लगेगी, जो मैंने 8 VS by N पाई वाला बताया है। फिफ्थ हार्मोनिक एलिमिनेट करना है, E will be 36, 72 degree. If the zero of reference sinusoids coincides with the zero of triangle, number of pulses are M. M is basically frequency modulation index. And if zero coincides with peak, it is M minus 1. V naught negative, I naught positive. D3, D4. Okay, it is fourth quadrant, D3, D4. Compared to single phase half bridge inverter, V naught full bridge, the value of the V naught becomes double. So power will become 4 times. Okay. RMS value of load current ठीक है, IPH RMS is VPH RMS by R. $13.2. ओके, चलो दो बचे। RMS value of output line voltage. ओके, ये वाला हमने क्लास में किया था क्या यार? .78, ठीक है, तो आंसर इज ए। तो दैट्स इट बच्चों, आर पावर इलेक्ट्रॉनिक्स रैंक इंप्रूवमेंट कोर्स इज नाउ ओवर। तो कल आप लोगों का ऑफ रहेगा एंड फ्रॉम डे आफ्टर टुमारो एवरी डे एट 4:30 PM वी विल कवर द EMFT रिवीजन, ठीक है, यूट्यूब पे भी और पेड में भी एवरी डे 4:30 आफ्टर अ डे, दैट इज फ्रॉम थर्सडे we will cover EMFT. Okay, चलिए, so now I will see you all day after tomorrow, but remember the timing will be 4:30 PM. Okay, और YouTube वाले बच्चों के लिए बेटा गेट 27 के कोर्सेज पे जो नया बैच स्टार्ट हो रहा है फ्राइडे से 30% ऑफ है यूजिंग द कोड EB30। जो भी रिकॉर्डेड कोर्सेज लॉन्च हुए हैं उस पे भी 30% ऑफ है यूजिंग EB30। और इसके अलावा अगर आप गेट 26 का रैंक इंप्रूवमेंट या कॉम्प्रिहेंसिव बैच लाइव खरीदते हो तो उस पर 70% ऑफ है यूजिंग YT70। टेस्ट सीरीज, आप फुल टेस्ट सीरीज या मॉक सीरीज खरीदते हो 70% ऑफ, कोड लेकिन है अंकित ESE, ठीक है। चलिए, तो मैं अब आप लोगों से 8 बजे मिलूंगा बेटा SSC JEE के स्ट्रैटेजी सेशन के लिए।